Good morning, all. We will start our class today. So, yesterday people completed the installation. Whoever has not done it, have you done till the last step? I was telling that processes were not running, that the data node is not running. It is because of some issues. Okay, actually, the user and the group which we have created, the Hadoop, it doesn't have the root permission. Okay, that is the reason it is not allowing to start the data node. I will show you what was the problem. We will create the user and the group for other one. Okay, Nilet user and group itself, so that it will be easy. Otherwise, we have to add the Hadoop user and the group name into and give the root user privileges. That is the reason it was not working. Okay, somehow I missed that. Okay, I will go to dot slash pwd. So inside Hadoop, if I list it, initially we have changed this user to Hadoop, right? So I have given it to Nilet and Nilet itself because this is the username Nilet. Okay, group under user also as Nilet. Only this has the root permission. What was happening for me is that two folders which we have created, no Hadoop data, HDFS, CD name node. Okay, and in this it will create some files in this. Okay, in that it was creating the current file in Nilate username because Hadoop does not have the root user permission. You remember we changed all the permissions so that we can easily access it without giving a sudo. In order to give root user permission for Hadoop, then you have to change a particular file like you have to switch. I'll tell you the procedure, but it is not necessary. You have to switch to the root user. Okay, and as a root user you have to edit this sudo user file. Here see user privileges they have given, no root user. Here you have to add Hadoop, and you have to give all the permission for that. Okay, but we don't need to change this file. Okay, so what we will do, we will remove this. No need to use this one. Okay, Hadoop user. What I will do is it is not quitting. No, what is the, it is not quitting. Okay, I will close this. I open a different terminal. So that use in order to give any user permission to any of the groups or the user, then you have to change the root user permission, then you have to change the sudo file. So now we will not do all those things, that is not necessary. Rather than what you will do, okay, remove all these files, the files in this path cdhdfs, okay, pwd. The files, two files are two folders are there, no two directories, which is a name node and data node. You delete this two now. Okay, then we will give the user and the root as a different uh, as a Nilet itself. Okay, remove star rf minus rm minus rf star, you remove this. Please log into your machine, do it along with me so that it will be done for you all. Then we can concentrate on the practical part. Okay, you remove these two files. Okay, Maria, Nishant, have you installed? Do it today itself. Okay, from maybe from next to next class we will start with programming. Then your machine should be ready by the time. Okay, can you log in and remove this file? These two files, Manigandan sir. We will change this user and the group as a Nilet. Okay, then it will work. Why? Because when you are giving a name node format, yesterday my units are asked why do we have to do a name node format. Name node format will start all the initial files. Okay, it will create all the initial files like metadata files. I told that a name node and data node, name node will contain where your this name node folder, this will contain the information of where your data is present in your data node. Okay, so it will create an initial metadata file. The file which is present in the name node is called the metadata file. Metadata file will contain the data about where your actual data are present in the present in the data node. So data nodes are the slave nodes. So that's what I was saying. And it will also initialize the where the data blocks are present in the hdfs. Hdfs is your file system, right? Where the data blocks are present, and that information also this will a name node format will do it. It will initialize it. That's the reason you have to do hdfs name node hyphen format. Okay, while I was doing it, it was trying to take a root user permission for creating the data node. Okay, for initializing the files in the data node. That's why my data node was not starting at all, process was not starting at all. So what we will do is we will create the user and the group as a Nilet itself, because Nilet has the root permission. Okay, where you can see it, you can see that in the etc password file also. Okay, there it will be, I think it will be there. Nilet. Okay, it has home Nilet. It is added over here, so it will have the root permissions while configuring itself. Okay, can you tell me, did you remove this one, this these two nodes? Okay, just remove these two nodes and recreate it. Two not nodes, but two four directories. Okay, remove these directories. I will also remove it. Okay, now it is not containing that. Then make directory name node and make a directory data node. Is this done? Saurav, you were doing. Saurav, right? Saurav, you were doing. Did you do it? Subrata Roy sir, Manigandan sir. Please remove this. We will change the user and the group to this Hadoop folder as Nilet. Then it will all work. Okay. Like a change ownership. Yes, sir. That's right. We go to our Hadoop folder. This one. Okay. User local Hadoop in this or user. Okay, user local. In this, we will change the mode. Change mode. I think change mode. Uh, change ownership. It is change ownership. It will have ask for sudo permission hyphen r. Everything we will change it to Nilet. Okay, Hadoop. Which folder? It is Hadoop folder. Complete Hadoop. Inside all the folders recursively, it will change it to the user and group as a Nilet. Saying invalid option. Uh, no, sir. If you have to give it like this, change own hyphen. saying invalid options. For supervisor, please come to this folder, user local. You give this uh, command over there. Change on hyphen or nilet. Space it should be there, sir. Minus RF space star. Star means it will remove all the contents inside that directory, in whichever directory you are in. Okay, you should be inside that HDFS directory. CD Hadoop data HDFS directory. Inside you will have this two, name node and data node. Okay, that you will remove it, IRM minus hyphen RF space star. Okay, after doing removing this, make directory. Okay, make these two directory. Why? Because it might be having old content. Anyway, we are in everything starting new only. That's why I remove it. I'm asking to remove and create. Make directory name node. For me, it is already existing, and make directory in data node. Delete it. So that's why we are doing the deletion. RM minus R, but not getting removed. It will get removed. It will. RM minus hyphen RF space star you have to give. Or remove it likewise. Can you share your screen, sir? How to share? There will be share option. SHARE down in your. You have connected from laptop, right? Laptop or desktop. Can you see the share option? SHARE, it will be there. Shared, and, but I could not see it, sir. Can you share it again? Okay, permission didn't. You can give sudo, sir, sudo, sudo permission. I'll ask for the control. Yeah, sudo rm space hyphen rf space star. Yeah, password if you give. Yes, it is a remote. Yes, please go to the. Okay, make directory. Yeah. Okay, I will share mine. Okay, after doing all these things, go to your user local. Okay, give that permission. Change ownership to hyphen r recursively to all the folders, Nilet. Okay, then Hadoop, which of the directory is Hadoop. Okay, then we will change the permission also. Change mode permission hyphen r to 777. All permission will give. It's okay. Enter to the Hadoop directory. That's all. This has to be done after only this change is needed because other things we have configured. Okay, we have configured all the configuration files in Hadoop. There are many configuration things we can do it, but whatever is necessary or with minimal configuration, it will work. Okay, you can work with you can run bring up the setup and you can work on that. Okay, so where did we made the configuration change in CD Hadoop in CD etc folder? There is pwd ls. If you see, these are the configuration files we changed. In that Hadoop env file we have changed where we told what is our Java home in this. Okay, Java home in this. Changing this file is optional. It may not be required to change it, but we have given the details of it. It also has something like a heap size and all. Okay, if you go down, whatever is necessary, heap size, maximum size, that to be used for running the Hadoop processes it is giving. You can change that. You can set that sizes, other things. But if it is minimal configurations for our learning purpose, you don't have to change all those things. Then we have changed the core site. In the core site we have mentioned where is our mission. Okay, where is our HDFS is running? It is our local host itself. It is running in the local host itself. Okay, and the port number for this is 9000 that we have given. And then afterwards we have changed the uh, which one, HDFS. Okay, HDFS site.xml. In this, please change this configuration, these two configuration. It should be dfs dot name node dot name dot dir. Okay, change this a name to this one. Everyone, I will update the this file. Okay, installation file. In this file, in the hdfs site.xml file, we will give all the information related to the hdfs. We will also tell the replication factor. We are using only this machine, that's why we gave the replication factor is 1 localhost, both the masters and the slaves. That the name node and the data nodes are going to be run in this machine itself. Okay, and we are giving two parts. We created two folders, right? A name node and data node. Okay, the name node will contain the information about the metadata. Okay, where it will be present, all will be present in this directory. Okay, name node directory. This is necessary that this folder should be present. Okay, otherwise during name node format also it gets created, but it is okay. It is good that we have this folder, okay, with all the permissions. And data node folder will have the information about where the data is present. Okay, where the data is present. So that's that information it will be creating in the data node. I will open and show what information it is holding. Okay, these two are enough to run our name node and data node. Okay, please change this one. It should be dfs dot name node. The property name is dfs dot name node dot name dot dir. Okay, guys, if there was a mistake in that, please change this. Which file you are asking? Shall I give 1919 in local laptop also? No, in your local laptop, you have, sir, you have to see which is your username, sir. Not Nilet, you should not give. Okay, guys, here I am giving Nilet because my username is a Nilet. Okay, group also I have create. I'm giving it as a Nilet. But in your local machine, whatever is the username that you have to give. Don't give this one. Okay, everyone, if you are setting up your Hadoop environment in your in your virtual box, okay, Oracle virtual box, whatever the username is, you might be having some username with your name, right? That you have to give. Sometimes it will be like jcody like that. I will give it. Okay, give it like that, otherwise it will not understand. If you are going to give nilite as a username, then yesterday we add, no, we have to add a username, and we also have to give sudo permissions to that username. Otherwise, sudo means root permission, sorry, not sudo, root permissions. Otherwise, while creating the block I mean information data node uh, information, that there are two files, okay, that it will create it, that time it will not understand. Only if you have sudo permission, that is a root permission, then only those files in the data node and the name node gets created, okay, otherwise it will not get created. That's the problem yesterday I faced. Okay, this is hdfs file, sir. In hdfs file, hdfs site.xml, you will change this one. The property name is dfs dot name node dot name dot dir. Change this one. Okay, let me know if this is done. Okay, you would have the file here in this in yours. It can be like that only. I will also change it. File colon will be there. It's fine. You can give it like that. Okay. Okay, everyone, you have done that. Maria, you have done. Saurav, have you done? Okay, Manigandan sir, both have done. Maria, please don't stop it. I will wait because I want you to do it. That's why I'm waiting it, even though it is taking. Maybe who is seeing the video might find it difficult, but it's okay. HDFS site will be in this path, sir. PWD in this path. User local Hadoop, etc Hadoop. No, it is not very long process. We are taking it long because we are waiting and doing, right. It is a short process only. First time when you do it, you will see that think that it is long. Only configuration files you have to change. That's all. And there were two mistakes I have done yesterday. That's why it is taking. It is not long process. Just download it, all configuration file, change it. It will run. That's it. Ma'am, do you do need to make changes in map right sites? No, there is no change in map right. I lost the configuration, ma'am. I will do it later from beginning because instead of okay, you should not remove Hadoop whole thing also. It should be from Hadoop data. Okay, that's why I showed. It should be from this folder. Hadoop data HDFS, these two file directories. I thought somebody would have deleted it. It's okay. You can actually delete complete Hadoop and do it completely. Yeah, you can delete the complete Hadoop, right? This Hadoop completely. This one you delete it and do it from this. Okay. Okay. You type it in the end. You can have it anywhere, Ramalan, in that commands. You can type it in the end because it is easy. If it is in the end, you can go and directly see it. Many configuration will keep adding it in the bash rc file. Okay, just to go to the end and vi slash dot bash rc, type it in the end. Dollar symbol, if you give, it will go to the end. Then you can add it in the end, both the configurations. Okay. Okay, now we have changed the hdfs site.xml. Other files, no need to change anything. Okay, I'll just go through the files. Then later MapRed site. Here it will tell, okay, the yarn is the resource manager which will do the map reducing task. Okay, it divides the tasks, allocates the tasks to different nodes. All these things we will see in further. Okay, so that map reduce, it's a processor. Okay, map reduce processor which does the map reduce tasks. That information we have to give it here. Okay, what is that framework name and the path, application path for the MapReduce job to do. MapReduce is the processing layer. Okay, there are Hadoop will come with two layers. We'll say that one is the HDFS and another is the MapReduce layers. Initially, it was developed like that only, that we saw in the PPT. Hadoop with HDFS and the MapReduce layer. HDFS is the storage area, and whereas a MapReduce is the processing layer. Okay, so this file contains these two information. This information about the map reduce, which is the yarn. Okay, I will save this and come out. Ma'am, inside Hadoop there is not there is a no, it is there, sir. Cd, this path is different from the one in the PPT, which maybe PPT I will change it then. Okay, I will revisit the PPT and I will change it. That might be okay. No problem in that. Okay, the path will be here, sir. In your Hadoop, CD etc will be there, sir. It will be there. You can list it and see. See, bin after bin etc is there. It's not there. Can you share your screen, sir? Quickly, we can see it. No, no, it is not user local Hadoop, sir. It is user local etc you have gone. See, and one more thing, uh, virtual. I think your username and group name is Subrata and virtual. Okay, can you give me control 1 minute? I'll request for the control. Okay. Okay, ls. So inside Hadoop you will have a etc. pwd or such file or directory. I think you have downloaded src, not bin directory. This is a source code you have downloaded, sir, from the internet. Yeah, you have downloaded the source code, sir. It should be bin 3.2.4 bin. If you go to that internet, that's why you are not seeing that folder. I'm just checking the Hadoop folder. Okay, here downloads is there. 3.2.4 and the binary have to download, so not source code. So binary only will have all those configurations. It is downloading. It will take some time, I think. Okay, it is fast for you. What I wanted to see is your groups vi is tc/groups. It's a new file. Slash it is. Sir, your username and group will be Subrata, I think. That's what I wanted to see. Okay, sir. That's why I have a con here. So you will be giving that change mode. After you extract it and do all the processes, you can give it like that. Okay, sir. So this one only you have to use, not the other one. What you have to do now is you will go to your downloads directory, then extract that file. Uh, Now you have the tar.gz, no, that you will extract it. X is at vf hadoop dot tar dot gz. It should have a sudo permission. Okay, 1 2 3. It is extracted. Then you can create that folder and all, and you can use it now. Okay, sir. Can you do that, sir? Subrata Roy, sir, can you do that? It is extracted. Then all the steps which we have done till now, you have to do that. Okay, I gave you the control. Sir, can you do that, right? Please do reply. Can you stop sharing? I will share that. Just you're calling. Okay. Just a moment. Okay, about the yarn site, we will give the about that is how the task has to be done. All this information will be present. The shuffling and all will talk it while we are doing map reduce. Okay, and that's all in this. Okay, once all this are done, uh, what we have to do is we have to do a name node format. Okay, the name node format will initialize the metadata. Okay, it is the first point which will initialize the metadata. Where it will get created is it we have created two folders, right? Name node and data node. In the name node I told, right, master node will contain the information about where the your actual data are present in your data nodes. Okay, there it will create your metadata, and a data node also gets initialized. Okay, this is the first point where your initial metadata will get created, and the log files and all related files to be created will be present. Okay, so what I will do now, I'll go, you can start the format the uh, name node anywhere, just for uh, complete, we will start it from here itself, no problem, anywhere you can start. This is the command. Okay, this is hdfs commands we will see. Like for the file traversing the file system, we have commands, right? ls command, cat command, pw command, kill command. Likewise, there are commands that to access the Hadoop storage, that is the hdfs. Okay, so hdfs name node hyphen format is the first step you will do it. Okay, this is the one time you will run this command. This is the one time activity. Okay, every time you will not change the name format, you will not do a format. Okay, because the metadata will contain the information about where the data are present. No, once you start working on it, that file gets updated. If you do a name node format afterwards, all the data inside the metadata will get deleted. So you will not do it formatting anytime afterwards. Okay, after you started working on this one. Okay, so I will do this. The processes are running for me, that's the reason it is not what it is not doing format. So I will stop all my processes first. I will tell about this again. Okay, so whoever has started running yesterday, stop all your process if you made any changes. Okay, the metadata information which is created after the name node, and after we add data into our data node, it will be present all the time. Okay, even if you shut down your machine and reboot your machine, it will be present all the time. Only thing is you should not format the node. If you do a formatting, then it will go to the initial state. It means it will remove all the information from the metadata, and it will go to the initial state. Okay, okay, all the nodes are stopped. Now I will do a format. So this is fine. Now we have to start the process. Okay, start the daemons, start the processes for the Hadoop environment to run it, to use it. Okay, start all dot sh. Okay, this is the script. Okay, this is a script file which runs will to start all the processes. This internally calls two processes which are nothing but start dfs. Dfs is the distributed file system, which is the HDFS, Hadoop file system. Okay, and also calls the yarn, yarn start yarn dot sh, start hyphen yarn dot sh. Okay, if you wanted to separately stop and start a particular process like the DFS and the yarn, you can start it separately. Otherwise, if you do start all dot sh, which will internally call start dot dfs and start dot yarn. Okay, that's what the idea over here is. One more thing. Okay, this is the scripts it will start. It means it will trigger these two scripts and then it will start all the process. Actually, these two start dot dfs, right? Control C I will do. This start.dfs internally will trigger Hadoop daemon processes. Okay, and the yarn daemon processes. Okay, Hadoop daemon start dot. Okay, I will write it in PPT, then it will be fine. Just for the general knowledge, what it internally, how what it is doing. Okay, for that reason, when I start to start doll all dot sh, this is a script. This will internally trigger two scripts. Okay, start dfs dot sh and start yarn dot sh. Okay, so this actually internally will trigger the Hadoop daemons. Okay, daemons, DAEMON dot sh script, which will start the process like a node, uh, name node, name node, data node, and a secondary name node. I will tell you what are all this. Okay, and this will start. The yarn will start the resource managers. Okay, this is related to the map reduce jobs and the node manager. Okay, we will see all this process are running. Okay, so a single command will start all these processes. These are the processes. We call this as daemon process because it will be keep on running in the background when we are working on with your Hadoop infrastructure, Hadoop framework. Okay, so I will start it now. Start hyphen all dot sh. It will take some time. Okay, so if in order to see whether the process has started, we use the command JPS. JPS is the Java uh, command, and that is all this process are Java related. It is written in Java only. Okay, so just starting the process, everything is Java related process. In order to see that, we will use the JPS command. Okay, now you can see all the processes started. Okay, JPS itself is taking as a process. The process is a name node, data node, node manager, secondary name node, and a resource manager. Resource manager is yarn. We have configured the yarn site.xml, right? So in the yarn site.xml, we can also give the number of about the memory sizes. Okay, how much memory each data node should use it, or how many cores, that is a CPU, it can use it. All this configuration we can give it. When information is like by defaultly, the memory which is used for by the resource manager for in each node will be in each data node will be 8 GB. Okay, and then cores, that is the CPU cores that it uses is 8 cores. Okay, that you can remember it. Okay, maybe they can ask what is the default memory used. Okay, and okay, this is all done. So what will happen now once we start all the processes? This there are two files, okay, which gets created. There is a file fs image, that is the file which holds the data, metadata information about where your data blocks information are present. So we have created that file in Hadoop data hdfs, and two directories we have created, right? Name node and data node. You go to name node. So in this you can see that file inside current. Okay, you can see these are the fs image files. Okay, this is the metadata file. This file, it is not in a readable format. Okay, you can open and see the file. Okay, I know some information about where your data is present. Now we have not put any data in your HDFS, so you don't have to worry about where it is present. These two files will be important, like FS image containing the metadata information, and this is the edit log. It contains the recent information. Okay, and that gets merged into the FS image, and it also has some file like a version which contains the information of when this is created. Okay, when this Hadoop is set up, when the name node format is done, contains information about the cluster ID. Okay, this is a cluster machine, right? Cluster ID, namespace ID, block pool, and all those things. Okay, and storage type is a name node. Similarly, there will be another file in your uh, data node. You can go to data node, pwd, in HDFS data node. That's the reason it is necessary to have these two folders and with proper permissions. Okay, here also you have current. I will explain what is this FS image and all these files. So it is not having FS image, but it is containing the information about the block. Okay, but no block, no, we didn't store any data, but it is containing defaultly some information. I This is a directory. Okay, I'm going into that directory and seeing what is there in that. Okay, it is containing so many information like current. You can go through that. The version, when it is created, version is a file. Okay, about the block ID. Block is nothing but data are stored in block. Don't worry, I will talk about it in few minutes. Okay, so about this. Okay, why I have told this, whenever once you do a data form, name node format, this gets created. Okay, this metadata files, that is fs image edit logs, gets created, and a version is also gets created. When you do a reformat of it, if you again give name node format, all this gets deleted. Okay, it gets reset to the current uh, data. Okay, version and all will change to the current date. Okay, that's the reason you should not change these files. So fs image, I told that it will hold the information about where the data is present in the data node. Okay, and the data node holds the information about where your data is present in your node itself. Node means the slave nodes where it is present. Okay, okay, so my processes are all running. What about yours? Whoever has configured. Saurav, you have done, I think. Is your process running? All your processes. What about others? I can give JPS. Anywhere you can give. Okay, no problem. Running, ma'am, all five. Very good. Okay. Okay, for others also it's running. It is easy only. It is not a big deal. It may look different, but it is easy. One or two times configure, you can do it. Name node and data node not running, checking on it. Name node and data node and not running. Permissions you have given, sir. Change ownership, is it coming properly? What is the error message you are seeing? Okay, sir. Can you didn't know name node format, right, sir? Otherwise, see, sometimes it will refer to the same cluster ID, data node and name node. If it is referring to old cluster ID, also it will not start. Do that, sir, because we have you would have removed that yeah, name node and data node, right? And you had made a change in the configurations. Sorry, username you have changed, right? Username and group name. It is necessary now to do it because that was only creating problem. So do for format, it will run. Okay, shall I move on further? Then we will see about the architectures, about Hadoop architecture. Then slowly we will move on to map reducer. Okay, we'll talk about all these processes. Okay, I'll take my PPT. Others, please do it. It is easy only. It is not a tedious process. Okay, only configuration. That file I will upload it. I will change it and upload it. Okay. So again, why do we have to have an Hadoop as a solution? The challenges which we saw about in the big data. The big data is a very huge, and the storing of that huge amount of a data, which is also a live stream data. Okay, it is not like you can store the data somewhere and keep remove the data every time and work on it. Same like I told in traditional databases, you archive the data, the tables and rows somewhere, information about the tables and rows somewhere, bring it to your processing, and then you can store it again. That is not possible here sometimes, because there will be the data which are coming in live streams. So you can think of the examples like stock markets and all, because it changes by minute, seconds by seconds. Okay, those kind of data if you have to work on with, which are all also huge volume, we need a solution. And also reading and processing of the this huge amount of data, okay, huge volume of data, we need a good processing unit. And reading of a data is like you just read the data and collect some information. Processing is where you get a business solution, right? You apply some logic over it, you get a solution out of it. It is like you load the data and you transform the data, uh, mine the data. Also mine the data means write some logic to get some valuable inputs or valuable outputs from the data, and store it back in the same format or in the different formats. So that is what the processing of data. And also some of other challenges we see is securing the data, okay. If it is this huge volume of data, if you wanted to secure it, if it is information so like which is coming from the defense, okay, departments, government defense department, then those things are for securing those data. You have to apply some encryption methods on that. You have to do once you do an encryption, you have to compress and store the data, or how to decompress the data. For all of these difficulties, the challenges like a huge volume and processing of a huge volume, reading of a huge volume, and applying security functionalities to the huge volume, for that we need a solution for which they have come up with the Hadoop. Okay, Hadoop is so the solution for that. And see, Hadoop, there are other, say they say distributions also along with Hadoop. It is there. Say similarly, like in Linux, we have other distributions like Linux. Linux is the operating systems, but it comes in different flavors, right? Like Ubuntu, CentOS, Fedora. Fedora was so very old, and what else is there? Any other distribution you can think of in Linux, you can say. Okay, now we are working in Ubuntu version. What else is there? CentOS, I can remember. Likewise, Hadoop also, it has come in a different distributions. Okay, one is the which one is the standard one, which is coming from the Apache Hadoop. Others are like from Amazon's, other vendors which are giving the Hadoop solutions. Distributed solutions are like Amazon Web Services, and also like IBM. Okay, IBM Big Insight. They give the solution for that. The solution in the sense, they take the underlying Hadoop architecture only from the uh, uh, Apache. Okay, on top of it, they will build their own different solutions, whatever based on their business and needs. And Cloudera is famous. Okay, and Mapr, and these are the different distribution which comes along with the Hadoop. Okay, underlyingly they will take Apache Hadoop framework, and on top of it, whatever they need it, they will apply to it. They need it means security options they can give differently. The processing they can apply. Okay, rather than using MapReduce, they can use Apache Spark for processing, something like that. Okay, and so when we talk about Hadoop, okay, there are two components that comes into picture, which is um, I'll write it. Then we will see the slides. Okay. When you say Hadoop, there are two components, which is major one. One is HDFS and another one is the MapReduce. Okay. Two layers or two components we can say. So HDFS is the file system. This is the storage unit. How to store the big data and how to process the big data, that is what the solution is, which is Hadoop framework. Okay, so for storage unit, there are big data sets you may have come across in your Python, right? Machine learning, you will be reading the data sets and doing some manipulation on that. No, that data sets you can store in the HDFS, and on this data set you can do some programming, okay, or processing. This MapReduce, we call it as a programming model. We can say it as a programming model, or we can do what I can say processing of the data. Okay, processing of the data. Say for example, as I told the other day, yesterday I was telling, right? Say you have a file with about an islet. Okay, about an islet, there is a file. There are some contents, and you have wanted to find the number of words repeated. Okay, number of words about. See, number of words Nilet is present in that file. Okay, so there is some word count program you are writing it. Okay, so this word count program will be put in the MapReduce processing, and it will give the uh, how many times the annihilate word has occurred. Likewise, some processing you can do in the MapReduce, whatever based on the user. Okay, this is one thing. And this MapReduce is the very old one. Okay, old, and it is commonly used. Mostly it is used anything you write on the top, this is how the architecture will be. Okay, you have your underlying hardware, and hardware, and on top of it you have your Hadoop configuration done. Okay, Hadoop will come up with MR, MapReduce, and HDFS, which is used for storage, and whatever other technologies present, right? Like Pig, you can write Pig scripts, Hive scripts to on your data to bring a business solution. Some solution you can, some analysis you can do. Okay, so this uses all the other technologies, uses the HDFS map reduce. Okay, HDFS to store your data it uses, and map reduce to do your processing. Okay, that's how we will see it, how it is actually doing. So this is done. Okay, we will see more about what is an HDFS, and the definition for Hadoop. We already know that it is an open source framework for storing data and running application on clusters with the commodity hardwares. Okay, commodity hardwares, we cannot say it as a, like our, just like our CPU, more than our, little more advanced than our machines, like whatever we have in our CPUs, right, at our home, little more advanced. Okay, uh, not like our basic laptops or basic desktops. Okay, little more advanced. Okay, now we will see about what is HDFS, about HDFS. Okay, the storage unit we will see. Mm, I'll remove this one. Okay, so HDFS, how the data is stored in your machine. We are saying data and all. How it is stored in your HDFS is file system. You understand, right? Similar like to your Linux file system, a Hadoop framework also comes with the HDFS file systems. Okay, just a moment. Okay, before going to this, we'll see what is the name node. Name node, I told you, the name node is the master node. There can be only one name node in your whole setup itself. You can have your only one name node. Okay, and there is this name node contains the metadata. I told metadata information are stored in a file called mfs image. Okay, this contains a complete information about where your data is present, all the information this will contain. And there is a something like edit log. Okay, this contains the recent information. Recent means uh, recent. Recent means, say for example, you are storing some data of 128 a file like a.txt file. You are recently trying to store this file into your HDFS. That information, recent information, will go to the first edit log. Okay, after some time the edit log will update the FSA image. Okay, this is this are the information which will be present in your name node. And there is another thing which is the secondary name node. Anyone wants to say what is the secondary name node? You can, by the name you can say what is a secondary name node. Come on. Replica of log files and fs image. Yes, it contains a replica of log files and fs image, but a secondary node, no name node, does not work as a name node. Okay, see, I told like data will be replicated in a data nodes, right? But that is not the case in the secondary name node. Secondary name node contains the as Saurabh told, the details about the log files, not log files, fs images and the edit log files. Over here also it will be present. Okay, just in, it will not act as a name node. Okay, when no, when name node goes down, secondary name node will not pick up the tasks. What it will do, it will contain the information of these logs, edit logs and fs image, and when whichever node is acting as a name node, to that it will transfer it. Okay, this will not act as a secondary name node. They may ask you in the interview or somewhere that which is the, what is the secondary name node. So okay, it is not a name node. Okay, it will work, it will store the fs image and edit logs. It will also try to uh, merge that the recent changes into the fs image, so that fs image will always contain the complete information about where the data are present. Okay, so anytime if you want to, if you restore this fs image, then you will know where the data are present. Okay, before furthermore into this, so about the hdfs is the storage unit. Okay, so how the data are stored, how data are stored in HDFS, that we will see it. Okay, all the data in your Hadoop will be divided into blocks, chunks of data. Okay, they say chunks of data. The data will be divided into chunks and stored in the in blocks. What do I mean is, say for example, you have a file size of 1000 MB. Yesterday we saw this will be divided into chunks, like each chunk will be of 128 MB. By default, it will divide the data into 128 MB size, okay, and store it in the blocks. Okay, how the structure will be? Say yesterday we saw that there is a rack, right? In the rack, you can have multiple data nodes. Okay, so now today we have configured only one data node. Say for example, data node 1, data node 2. Likewise, inside this 1000 MB will be divided and stored in the form of blocks, and we say that chunks of data stored in blocks. Okay, this block is will be of size 128 MB. This size is configurable. Okay, initially before Hadoop 2 it is a 64 MB. Now they have changed it to 128 MB of data. Okay, what 1000 megabytes of data, if I say for example, I have a file a.txt and it is containing, the size of the file is 1000 MB. Okay, and that file will be divided into 128 MB and stored in a block. Another 128 in another block it can be stored. Okay, in block 1, block 2, and another 128. How much you can divide 128 128? I think 4 times something it will come. All this will be stored in block. The size of the block is 128 MB, and this is configurable. Okay, okay. So in one rack you can store multiple informations, and okay, so when you are dividing this 1000 MB, sometimes it will come lesser than 1000 MB, right? So how it will store in the block is lesser than or equal to 128 MB of a data. You can store it in your block. Likewise, it will get stored. And what else? And okay, say for example, I'm saying that only one block is stored in one rack. Somebody is talking. Amalan, Amalan, you have any doubts? Okay. So if there is another concept here, this rack you understand? No, yesterday I was telling, right? There can be multiple data nodes inside a rack itself. Likewise, you can scale it. Okay, a rack they will call, and each will be connected. Okay, through the network. Okay, network wires or something. So you can have a multiple racks and multiple nodes. Say for example, one rack itself can have 10 data nodes. Okay, 10 data nodes, and this can have 10 data nodes. So likewise, you can keep scaling it. The That's why it is the scalability is high in the Hadoop. Okay, so in HDFS, how the data is stored? HDFS file system, this data are divided into blocks of 128 MB size, and it is stored. Okay, say for example, if any node goes down, that is also needed, right? It should be reliable data. One, if a rack goes down or a node goes down, complete node goes down, then what that data will be lost, right? What how what will come into picture is, now it will come into picture of this replication factor. Okay, replication factor for Hadoop HDFS is 3 by default. Okay, you can replicate it to any number of times, but it is enough. I mean, they had have come up with a scale is 3 is enough. Okay, if even if one goes down, then it is very easy that you can take it. Even in the worst case, if two nodes data nodes goes down, then you can take it from a different node itself. So how the replication factor, then how it will be stored is, say for example, if this is a rack 1, in that I have a multiple data nodes. Okay, data node 1 and data node 2, and if it is a rack 2, then here also I have multiple nodes. So the data which I'm dividing this 1000 MB, this can be a block 1, block 2, okay, block 3. Okay, so block 1 can be here, block 1 can be here, block 1 can be here, and you can have a block 2 here, block 2 here, and block 2 here. So not in the same node, obviously, right? If this node goes, obviously it doesn't make any sense. You can have multiple racks. You can also distribute between three racks, say block 2 here. Okay, so if one rack goes down itself, or one data node, this is data node, goes down itself, then you can take the data from the other node. You can means the Hadoop will, HDFS will uh, look for the data from the other node, and it will use that data for processing. Okay, this is how the replication happens. So it is why they have given come up with a size of a 128 MB block size is, see, lesser than that, if you take any value, they have arrived, like they would have done some research and arrived at this number. So thinking that if it is lesser than that, like if it is 64 MB and all, then you have to divide this data so many times, right? The division of this data 1000 MB, dividing of that, it will be so many number of times. 64, how many 64s will be there? Double the time of 128, right? And that many blocks you have to store it in your rack. And if it is more than that, processing, that is what the difficulty we face, right? In traditional processing of huge volume of a data, more data size is not, it will take time, all right. It will processing of a more larger, more than this size, may take a larger time, all right. That's the reason they have come up with a nominal bytes block size as a 128 block size. When I say, it is the amount of data that is stored in each block. Okay. Any doubts till this? Okay, for others. Okay, if you have your company, any company, you can go to the server room and see. Okay, there will be many racks will be there. Then there will be many servers running, like multiple servers will be running. Then if you are having an Hadoop infrastructure itself, then you can see multiple data nodes will be present, and all of this, that where your block has to be present, and where it where your data has to be present. Okay, block one means, say for example, I say this is data science class. Okay, we imagine that this is 1000 MB, and I divide this as a 128 MB, and this is getting divided as 128. This is taken care by the Hadoop itself. Okay, how to divide it and store it. Okay, so this 128 MB, I store it in this data node. Okay, and 128, the second one is stored here, say for example, and it is replicated also. So where this is data has to be stored, where it has to be replicated, all these are taken care by the yarn. Okay, yarn is also called the yet another resource negotiator. Okay, this will the size of uh, what we say, how the memory size we have to give for the data. Okay, for storing the blocks, or how much memory we have to give, and how to use the core for processing, and where the data should be present, all this taken care by the yarn. Okay, this is another server itself which takes care of all these things. Okay. What else I have to tell in this, how data is stored we saw. Okay, I think we will see the PPT, then it will be same. Okay, same thing only. Okay, another concept is about the switch. Switch I will tell. Switch, you understand, right? If you are talking about a network, all the racks will be connected to a switch. Okay, I'll clear all those things. So what they say is that so we have racks. To draw small, multiple racks are there. So there is a switch in each rack. Okay, switch, what it will do in a networking, it will connect the multiple points, right? Node points. Like here we have a data nodes, multiple data nodes, right? Data node 1, data node 2, and many. Similarly, we have a data node, many data nodes here also. So all these are connected internally, then all this connects to the switch. Okay, and this switch will be connecting to the another core switch. There is a something like a core switch. Okay, uh, all these racks will be connected to this core switch, and this core switch will be connected to the your name node machine, which is your manager. Okay, there will be only one name node, and the name node will again will be connected with your secondary name node. Okay, secondary name node. Then in name node, you have a FSA image file. This contains the details about where your data is present. Okay, and any change. Say for example, you are adding blocks information. Okay, blocks here, block here, or data is stored in your HDFS. Okay, then that will get first updated in your edit log, which will get again updated in your FS image. This is the permanent one. Okay, you won't do name node format, otherwise this will get, you will get I mean you will lose the content of the FS image. Okay, this is the permanent file, which contains the complete information about your datas. Okay, and this once this is like this will not come into picture when this is added later only. Okay, before and all we don't have a name node, because say for example, if a name node goes down, then this will not take over. Okay, but it will have a complete information about the FS image, and it will uh, that information it will load to whichever is working again as a name node. Okay, some other node can work as a name node. That name node, it will pass all this information to that as name node. Okay. And this all this racks, right, all this data nodes will pass, there is something like heartbeat, okay, information to the name node. Okay, the it will pass the heartbeat information, means whether the node is alive or not. All this information will be passed to the name node, that it will get stored in your metadata. Okay, if any of the node goes down, or the if complete rack goes down, that information will be updated in your fs image. Okay, so the complete working how it will happen is, a client is like a user, I, okay, I wanted to do store any data or read any data from your HDFS. The client will send a request, okay, to the name node. Okay, saying that I wanted to read some data. Okay, some say for example in that this is a data science class I have written. No, I wanted to read science data, science word from the data. So name node, what it will do, it will give the fs, if it will search in the fs image where the science word is present. Maybe say for example it is present in the block here in data node 1, then this information, the rack 1 data node 1 of this rack information, it will give to the client. Okay, name node will give to the client, then client will directly access this rack and do the processing or reading, whatever they will write some program, right? We will write some program, some map reduce program and all, and that it will read or do processing with this data present in the data block. This is how the request will go. Okay, manager, that is manager node, will not do any processing and all, it will only give the information. It will search in its fs image and find where this data is present, and it gives to the client. This is like a reading request. And if you want to store the data, like I told, like 1000 MB, that a.txt, which is of 1000 MB, if we wanted to store the data, then that information, name node will take it from the data node, sorry, from the client, and that will be given to the yarn. Okay, yarn will distribute it, and it will store it in your racks, any of the racks whichever is available. All the distribution and the replication processing are all taken care by the yarn itself. Okay, if you are going to do any development on yarn itself, then you can go in detail and learn. But now our aim is not that. Our aim is to understand the architecture and work on with map reduce jobs, processing of data and storing of data. Okay, is this okay, guys? What else I have to tell in this? Then we can go to the slides. Data blocks you understood, no? So and one more thing is, this a name node, this is the that manager node, that is some, not manager, master node, which is the name node, should will be normally of high end. High end means it will be a reliable, reliable computer. Why? Because it is storing the information, right? Storing the complete fs image, right, metadata information, so that it should not it should be reliable, it should not go down, like it should not be like crashed all the time likewise. That's the reason they will take on higher end machine, higher end servers for this. Whereas this data node servers and all can be of a low ends. Okay, the cpus or the machines which where you use that as a data node can be of low end. Why? Because even if one goes down, see, you are going to keep adding so many number of data nodes. You can imagine, right? Thousands of thousand nodes can be added. Okay, it is not like very huge, like whatever I showed, three racks and all. So many racks you can add. So even if one goes down, data is replicated thrice. So it will be easy for I mean, availability, data availability is high. That's why they go for the commodity hardwares for this. Okay, for whereas when you talk about a master node, which is the name node, it will be good. The configuration should be good. It will be little high end. Okay, guys. Then we will go to the slides. We will move on, I mean, read through the slides. Any doubts you can ask me. Any doubts till now? Okay, I'm moving on to the slide. So whenever you have an Hadoop framework and you say that Hadoop framework is present, underlinely there will be your hardware, right? Whatever your hardware is. Now we have your hardware like Intel, whatever is there, on which we have the operating system. We are using the Linux operating system. It can be, as I told, like Ubuntu or CentOS also can work. On top of it, we need the Java virtual machine to run the Hadoop processes. Okay, then it is having the basic units like components like HDFS, the storage unit, and the processing unit. Okay, on top of it you can have your applications. Okay, specific like a pig, hive, scoop, and avro. So pig is like developed by different companies. Okay, actually I forgot, pig is by anyone, no, like pig is by one has developed by Yahoo, hive I think, one by Facebook. Forgot which one is that. Okay, developed for their needs. Okay, this will, if you wanted to run your processing, if you wanted to send commands to your HDFS. Okay, I mean in your Hadoop environment, you can HDFS, you are running commands means you are running commands to your data, because data is stored in HDFS, right? You are running commands to your data to do the processing. Okay, so Hive will have SQL queries directly. Whatever we are seeing, no, my SQL queries that you can directly execute use if you put the environment Hive environment, and if it is a pig, there are pig scripts. Okay, that is also easy. Only pig scripts you can run it. Okay, then a scoop is of like a mm, you can connect with your databases, traditional databases. Okay, and if you want, in case if you connect to your traditional databases and just process that data uh, values in the database, and for that we can use the scoop. And Avro I forgot. Other things are like a streaming data is like a live streaming videos, audios, which are the stock market informations, all those are streaming data, like live data. That for that you can use this Flume framework, and different framework are there. And HBase, HBase, if you are going to see databases, we have seen multiple types of databases, right? A NoSQL database, SQL database, which is the traditional one, which suffice DBMS, relational database. And there are also different databases like column oriented databases. Okay, and also saw um, key value pair databases. Okay, map databases, key value pair databases. So if you wanted to work on like column oriented, we will see, we are going to learn HBase. So if you are going to work on column oriented databases, then you can use the HBase. You can store that type of data into HBase, and you can process those data. Okay, everything will start, the processing will be done by the map reduce framework only. Okay, which is handled by the yarn. Okay, then other things, some applications, in order to pass the queries, or if you wanted to find the statistics and all. See how you can relate it. Whatever you are learning now is like, see, you are doing ML, right? ML, what it will do, machine learning. Some algorithms you apply to your data, and you will arrive at some solutions, right? Or you see the graphs how it will behave. Okay, so you can store your data in your projects also. How you can do, you take your data set, you store it in your HDFS. You can do the processing here itself. Okay, some initial level of processing using MapReduce you can bring it. Otherwise, you try to connect with your the result which you are getting, no, after the MapReduce, after the processing of your initial data, that you can pass it to your ML. Okay, and you can arrive the mean you can do a machine learning logic, if you can apply to your resultant data which from the map reduce. Okay, likewise you think of applying all the technologies whatever you are learning here and use it. Okay, in that cases, this any one of this you can use. Either pig scripts you can write, hive script you can write to analyze your data from the HDFS, or you can, if it is a streaming data like Netflix, okay, or a Twitter information. Likewise, you wanted to process it, that and all you can do. We'll see case studies later on. Okay, And other things, see, if when the framework comes into picture, no, you have to have a backup and recovery mechanism, and deployment security you have to have, and management. This may change according to vendors. Okay, so initially this is how they will set up here the Hadoop Apache environment, sorry, Hadoop environment in any company, and on top of it they can add anything. And this are business BI is business intelligence applications, which to find the statistics or the reports, and you can also have the ML. Okay, to do on this. Even Spark will do ML. We'll see about Spark later on. Not confused with the Hadoop. Okay. Ma'am, where Yarn stands in this architecture, Yarn will be somewhere in this here. Before here, you can put. Okay, Hadoop. Hadoop configuration itself will have Yarn here itself. Okay, then you can think of like MMR components only, right? And HDFS. But in pictorially, they will show it like this. Yarn. Okay, Hadoop. And over this one, MR and HDFS. Fine. Okay. So about the HDFS, it is like read once and write once and read many times. Okay, so you put your data into the HDFS data sets. Okay, into your HDFS means into your data node, into as a block format. You don't have to worry about how to store as a block format and all. But when you are going for scalability and all, size of block, if you wanted to increase it, that is also possible using the configuration files. We saw HDFS site.xml. No, those configuration you can Google through it. Okay, many configurations are there. There you can change the size of it. Okay, there you put it in your HDFS. It will be there, and you can read it many times. So warm satisfies worms. Divide the files into big blocks and distribute across the cluster. So all together, the whole environment, right, we call it as a this complete environment, we call it as a cluster. Okay. Okay, and stores multiple replicas of each block for reliability. Multiple replicas, by default it is 3. Okay, programs can ask where do the pieces of my file live. That information is given by the where my file lives. That information is given by the fs image, which is present in the name node. Okay, name node only has that information. Okay, and looks like a file system. Okay, it looks like a file system. That's what they are saying. This we will see. I will show it now. Okay, HDFS, it is the distributed fashion. So it Hadoop works in the distributed fashion. It means the files are distributed in stored in different data nodes. Processing can happen in different data nodes. Processing means analyzing of your data. Okay, arriving any solution we want, it can happen in a different data nodes at the same time. Okay, that is what the distributed fashion is. It is fault tolerance, we know it. Scalable, any number of nodes you can add it. Extremely easy to expand, you can add any thousands of nodes, and so that you can have huge volume of data. Okay, HDFS is primary distributed storage for Hadoop applications. Okay, HDFS provides the interface for applications to move themselves closer to the data. Okay, so it is what they are saying is you can work with the data itself directly. Whoever the client is contacting and wanted to process your data, they can directly have the information where your data is present and work on the data. Okay, is designed to just work. However, a working knowledge helps in the diagnostic and improvements. So when you learn about the basics, then you can go dig in deeper and understand many configurations of that. Okay. Furthermore, this is the architecture. Name node contains metadata information about the replicas and some temporary file information and all those things. Okay, and client will ask the name node where my data is present. Name node, these are in, I'm talking in plain English terms. So, okay, it will actually it will name node will give it the information about where the data node information are, like a file or something. Okay, so I'm talking plain English terms. If you want, you can go and check how it is actually giving the data and all stuffs. Okay, well, we are doing it, we will see. Then it will go and read the I mean do the processing or read the data from the data nodes directly from the slave nodes directly. Okay, this they can distribute as a rack 1 and rack 2. It means these three data nodes are present in rack 1, like rack 3 data nodes are present, and in this rack there are only two data nodes are present with containing blocks. Okay, so name node is the master service, determines and maintains how the chunks of data are distributed across the data nodes, and data node stores the chunks of data in the form of blocks and is responsible for replicating the chunks across the data nodes. Okay, so this the architecture, it contains a fs image. Okay, it is an image file. We cannot read that file. It contains complete information about complete, okay guys, complete information about the whole rack, whole that framework itself, infrastructure itself, whatever is developed. Okay, and this hdfs clients, when you are going to store any data or into your HDFS, and whatever the commands we give, right, that is called the, we gave one command, right, HDFS name node format. Those are the client commands which we will give. There are commands we will write like ls, if put commands and all are there, that we will write it to those are client commands. Okay, that we will write it to put our data into our file system likewise. Okay, and it is also connected with the secondary name node for the backup, namespace backup only. It is not the backup of the name node. Okay, it is not the backup of the if even if it goes down, it will not come up. It will only store the data, that's it. Okay, whichever is the name node, again it is uh, given by the architecture, or if the user has configured, that node will take the copy of this fs image here to that node and it will work. Okay, replication, balancing and heartbeats. Heartbeat I told, like all the name nodes, it will give the information about whether it is alive or dead, all the information to this name node periodically. Okay, and where the data are present, I say HDFS and all, actually it is present in the local disks only, right? Local disks is like, see, we have created name node two folders, right? Two directories, name node and the data node. Okay, the data node will contain information about where the data is present in the disk. If I say it is stored in the form of a blocks also is stored in the disk, right? Underlyingly some hardware disk only it will go and store, right? That is, that information will be present in the data node folder. Okay, and till now any doubts? No, right? Shall I'll continue? Okay, and about the DFS architecture, same thing it is there. The master node and data nodes are also called worker nodes or slave nodes or data nodes are daemon running in the Java virtual machine. Okay, all will be running in the Java virtual machine only. Okay, that's why you need the Java, and name node contains the hierarchy of a data directory names and the file names information. It is a memory based service. Okay, so the files, that fs image will have an image file that contains all the information. Okay, block map is every block whichever we are it is creating, no, where the data is stored, that will have a block id that you can see it in your fs data node folder is there, no, directory. You go there, you can see block ids or not. Once we store the data, we will see it, and the metadata will have information about the permission, ACL. Actually, I forgot it. Tomorrow I will tell. Okay, this ACL we have it in our configuration yarn also. I forgot it. Will tell tomorrow. ACL. Okay, about the block size information, replication level, access and the last modified data, user quotas, who will be given the access to access the blocks. Okay, the client which is connected, no, that information will be present in your metadata. Okay, so this is the name node. Actually, what all name node contains, they have given this one. Name node namespace, it contains blocks, we map block informations and the metadata. ACL I will tell tomorrow, I forgot actually. If you can see it also, it's fine, you can tell me. Okay, so this is the client is the any query or to which says store it the data in the HDFS or read it from the HDFS. The flow happens like this. It sends a request to the name node to add a file. If I'm going to add a file to HDFS, name node gives the client a list to the path where the file is present. For every block, the client will request the name node to provide the new block ID, a list of the destination data nodes. All this information it gets from the name node. Okay, block ID and the where it has to put it. The client will write the block directly to the first data node and to the next data node likewise. Okay, the first data node pipelines their replication to the next data node. So actually whichever is stored in the first data node, that it will take it for processing and it will copy it to the other nodes. Actually here it is writing, so it will write it to the first data node and it will copy to the further data nodes. That's what they are saying it here. Okay, then furthermore, so these are all descriptions about everything. Okay, we'll go through this. Okay, HDFS a name node. I told that. I think don't need to repeat it. The tasks will be like it's manages the file system namespace. Okay, namespace is like how we can say namespace. It is like the information only, right? Where it is present, that information it will store. Okay, it regulates the client access to the files or executes a file system like a naming, closing, opening of directories, all these things it will take care. And it will also sends a heartbeat and a block report to the name node. All data nodes will send an heartbeat and it's a report to the data node. Okay, it ensures that the name nodes are alive. A block report contains a list of the blocks of the name node. You can read through this. Okay, files present in the name node metadata are as follows. What are the files? FS image I told. Okay, it is an image file. It contains a complete namespace information about the data nodes and file inodes. Inodes, have you people come across? Inode. Every file which is created, it will be associated with an inode value. Linux you would have yeah, Linux. This is Linux machine only, no? See, we are storing the data in Linux only. That's why, yeah, the file system, right? The files which are stored will have an inode information. Okay, it's an internal representation of a file or a directory. I will show you. Okay, because whenever you create a file, the inode will get associated with that, right? With that, right? One number will get associated with that. That inode will also be there in HDFS because this is also works like a Linux file system only. You will create directories and files in that. I will show it. Okay, and the edit log is like recent information it will have. Okay, they will ask sometimes in an interview maybe like which one gets updated. Edit log only first gets updated, then it will be uh, uh, updated in the FS image. Okay, and the HDFS is no data node is the slave and read and write operation as per the request of the client it will perform. Okay, or runs on the commodity software. A task of a data node is a block replication. It does creation, deletion, replication, and manages the data storage. Okay. By default, the frequency is set to sends a heartbeat. Okay, so it will send heartbeat every 3 seconds. That's to the name node. Okay, this also you can remember. And secondary name node contains the information about the FS image and edit logs, which is present in the name node from that name node. Okay, it keeps edit log size within the limit and it will what it will do is secondary name node there is a something like a checkpoint. Okay, checkpoint configuration. Checkpointing is like this configuration if you give in our where we will give, I think it in HDFS only, HDFS site.xml. Okay, for the secondary name node, if you give this checkpointing, uh, by default it will take 1 hour. In every 1 hour, it will retrieve take the data from the name node and keep it in secondary name node, guys. That's what every 1 hour. This configuration you can change it. Okay, so that way it will be updated every 1 hour. The FS image data and the edit log data in 1 hour it will take it from every 1 hour it will take it from the name node and keep it in its memory. Okay, so the checkpoint is a node which periodically creates a checkpoints of the namespace. This is like this configuration you can give the checkpoint which is associated with the secondary name node. Okay, backup node is keeps in memory and up to date copy. If you can configure a backup node also, backup node for the name node you can configure. Backup node and secondary name node are not the same. I told it. This backup node is the backup node for name node. Okay, if that goes down, you can say this backup node can act as a name node. Secondary name node is different. That activity itself is different. Okay, so replication and the block placement, uh, that's what they're saying, like block one. SGFS is designed to assume, handle, and discuss system failures. Any failures, how it will handle it. So rack one, data node one, you are having block one here. In rack two, in data node two, you are having it. In rack three, in data node three, you are having it. Okay. Likewise, block two also is replicated in same in two places. Fine. This is about the replication. And about the blocks, it is not 164, it is 128 now. Okay, this is old information. There are smallest unit of data in the file system. We can go through this, I think. So replication management is it will replicate the nodes like this. Sorry, it replicates the data like this. Okay, you go through this. If any doubts, you can ask me. Rack awareness is like where the data nodes are present in large cluster in order to improve the network traffic while reading and writing. Name node chooses the data node which is closer to the same rack or nearby rack to read. What they're saying is, if I say I store a data block here, okay, first till this data node is complete, memory is filled up, it will keep adding here only. Okay, in the first block 1, block 2, and block 3. Why? Because if you keep if the name node keeps the data blocks in a different, say for a nth rack, okay, data center nth rack, then you have to uh, I mean, find out where that data block is present, right? In order to avoid that network traffic, this normally takes the rack which is closer to it. Network traffic, you understand, right? It depends on where the rack is present. Location also it depends, which is closer to it, and the node which is closer to it. Unless until it is filled, it will keep adding into that block. Okay, and this is there is a network awareness algorithm they have written, okay, for how to replicate your data into the rack and to achieve high availability, reliability, all stuff, and the performance of the cluster, to also improve the network bandwidth. This also I can go through. And this is what I told. If it is a multiple rack cluster, then switch will come into picture. Okay, the communication will happen via the switch. Okay, and this is a secondary name node. Same thing they have given. These are name nodes. You can think this is rack 1, rack 2, rack n. So the name node knows where where all the blocks are present. So if one goes down also, it can take the data from the other, because the name node has the information about it. It is all okay. What they are saying in this point is, if the node goes down, that data will be replicated in other node. Okay, that is taken care by name node itself. See, it is like another complete ocean only, like another technology only, another domain only, right? Big data. You can learn more in this. It will be very interesting also. Okay. So if node goes rat goes down also, then what will happen? They everything name node knows. It knows about the blocks. It knows about the structure, complete topology or the structure of the cluster. So it is easy to find other data from other, or it is easy to replicate the data from the lost node or rack. That is what. Okay, if I'm gone down, and what will happen? It is like a something like single point of a failure. So if you have a backup node for the name node, then that can be used to as a name node, and secondary name node will have the FS image, right? Complete information that it will transfer it to the backup node. Now it will become the name node, and it will work as a name node. Mm, okay. Okay, that is all. This I will tell you, okay, about this rack. I will tell when we are talking about map reduce, because there is one information is like trying to keep the uh, most of the data nearer to the name node and in a single rack itself. Okay, so that network traffic can be avoided. No need to traverse to other racks. Likewise, that I will tell you later on. Okay, guys, any doubts? Is this okay? How is it? Boring or how is it? You're finding it interesting? More are there. We'll see. Not, I mean, about the architecture and all. That's all. Not much. But when we start working on the map reduce, it will be nice. That is all for today. We will do a cluster installation tomorrow. Okay, we'll start that also. So please, everyone, finish the single node installation today itself. But difficult to cover after office. Difficult to cover after office revision. Okay. Okay, I will put a book. Okay, Hadoop. You can download also. It is available. Hadoop. What is that book name? I forgot. 1 minute. Hadoop Definitive Guide. This is a very nice book. I also refer this book. You people also can refer it. You can spend hours in this book. Visible. No, this one. I will put it in the Vidya portal. Okay, download this book. Keep it with you. If you can purchase, also you can purchase. Anyway, if you are going to work in this data science, you will need it. Okay, all good books you purchase and keep. Okay, this latest edition is old only. You can find, I mean, this is the fourth edition only. You can take the fourth edition. They have some case studies also. They talk about yarn, everything in detail in this. It is a good book. Okay, I'll put that. Okay, guys, that is all for now. Any doubts you can ask me. Otherwise, we will see tomorrow. There is one other book, Hadoop in Practice. That also you can refer. Both I will put. This will have a little more insight information. That will be like from basics to everything. This book also good. You can refer this to. First you refer that book. That is very good. Okay, then you can come to this one. Advanced books you can go. Okay, that is all. Thank you. Thank you everyone. We'll meet tomorrow. Okay. A video, ma'am. What video, Amaland? Okay, I will put it. I did not take it properly first class. Okay, I will put it anyway. Okay, both everything I will put. Okay, thank you.